Hello, and welcome to Image Acquisition. Today, we're going to be gathering some data on NGC 281, which is the Pac-Man Nebula. To do this, we're going to be using Sequence Generator Pro. Now, be aware, this is not a tutorial on how to use Sequence Generator Pro, although I will be giving you some brief introductions into the software to let you understand how the software is able to produce the kinds of images with the equipment and under the circumstances of which you actually need to have it done. So here we go with image acquisition. Okay, here we are inside of Sequence Generator Pro, and we're going to come down to the equipment profile, and first is identification of different equipment, telescopes and cameras, filters, focus, telescope, plate solve, auto guider, and any other switches and so on. This is where you would set all that information up. So we're going to choose the FSQ 106 and a 694, and we're going to take a look at the plate scale, seconds per pixel. That's very, very important. Look at the filters that we're going to be using. They are defined here. And if we have focus points and so forth, they can be entered right there. Our focuser is going to be the Moonlight Express on the telescope, and we're going to be using autofocus on this as well. The telescope, of course, is sitting on an Astrophysics 900 mount. That has to be defined. Mount meridian flip has to be set up. This is where you would do that. And that number needs to be 3 to 5 seconds in there. We'll change that. The plate solvers, we're going to be using the ANSVR and Astrometry and ASTAP. And we want to save that information. The next thing we need to do is define our target. To do that, we come up to the Tools and come down to the Framing and Mosaic wizard. We enter the object, NGC 281, and do a fetch, and it brings up the object. Now we've already defined what our camera and telescope are, so now we can actually define exactly what the image was going to look like. And that's the way I want to frame it in the telescope. Once I'm happy with that, I can create the actual file, the imaging file, and there you have it. That's all there is to actually defining your target for the night and allowing a telescope to get to it. All right, here we have our imaging screen. There's our target. We would connect all of our equipment right over there with those buttons. So to define the actual sequence, we click Run on all of the images, set them up. These are the filters, defining exactly what they are. Then we define what suffix we want on that image file, usually corresponding to the filter itself. Luminous, hydrogen, oxygen, and sulfur. Next we define the exposure. I usually do 2 minutes on luminescence and 5 minutes on hydrogen, oxygen, and sulfur. Imaging 2 by 2 because of the atmosphere here. There's no point going 1 by 1 because the seeing doesn't justify it. Then identify how many frames I want of each one of the colors. I want to rotate through all of the filters rather than having to just stay on one all the time. I define where I want the files to be stored. And then I also define exactly what information I want on those files, like how long was the image, what filter was the image, and so on. And then I can run the sequence from right there. Okay, here we have our first hydrogen screen. On the left-hand side, you can see an image histogram showing you exactly how the image is stretched across the screen. Below that, we have the frame and focus if you want to take an individual image to frame it up or move it around or whatever you want to do with it. Below that, we have the focus control that allows you to identify the focus value for each one of the filters. And of course, this will be automatic with the system once that you begin imaging. Below that, we have the manual focus control. And then we come up to the filter wheel. It shows you which filter is actually being used at any given point in time. Next to that, we have the temperature that's actually on the camera. And immediately to the right, we have the guiding information. This is absolutely critical. The blue line indicates the right ascension, and the red line indicates the value, the quality of the deck guiding. Below that, of course, is the actual image of the frame of the guiding camera and the star that it's locked in on. And last but not least, of course, is the actual imaging screen itself. Here we see the progress that's been made on each one of the filters. Right now we are just beginning our exercise as well. We only have one image, and that happens to be in hydrogen. So it shows you exactly what progress you have had throughout the entire night. On the bottom where it says remaining, if you come straight down from the repeat column, you find how many hours are left in this imaging cycle. That's really important to identify when you have to do something like prepare for shutdown or whatever else. And of course, on the right is the actual progress on each one of the filters. So this is the hydrogen screen. And here is the oxygen screen. I call your attention to the guiding chart up on the upper right-hand corner. You notice we had a little bit of a change in the sky that kicked the declination up. It could have been a puff of wind as well that interrupted the guiding. And on the bottom right, of course, you can see the progress of the various filters as we go through the night. Finally, we come to the sulfur filter. And you can see this is pretty typical of the images that you have seen so far for the hydrogen, the oxygen, and the sulfur. This, of course, is the sulfur screen. And you can see the guiding is quite good up there in the upper right-hand corner. So these are pretty typical of what the kinds of responses you're going to get to the various filters on objects in the sky. Finally, after 9 hours of integration, in hydrogen, sulfur, and oxygen, we have the Pac-Man Nebula, processed in PixInsight.